Smart Security and Parking Assistant using ESP-WROOM-32 Module. Hi everyone, my name is Dr. Konark Sharma. In this lecture, we will learn about the basic overview of Smart Security and Parking Assistant using ESP-WROOM-32 Module from Aniket Singh, Deepak Goyal and Ojas Garg. Upon completion of this lecture, learners will be able to understand about the basic overview of Smart Security and Parking Assistant using ESP-WROOM-32 Module. So, let's get it started.
KONARK'S research. Subscribe now.
Hi, we are here to present a project on Smart Security and Parking Assistant. Myself Deepak and I have done the hardware part of the project.
I am Moses and I have done the software part of the project.
I am Aniket. I have done the research and market analysis.
In today's world, where vehicle safety, energy efficiency and affordability are essential, our microprocessor-based system offers a smart and cost-effective solution. Built using the ESP-32 ultrasonic sensors and a buzzer, the total cost is under 1,000 rupees, far cheaper than the commercial systems with proprietary hardware and installation fees. The system features dual functionality via a simple switch. The on activates a parking mode, guiding the driver with ultrasonic sensors, and the off switches to security mode, monitoring the area around the vehicle. To avoid false alerts, an SOS is only triggered when the door handle is touched, not just when someone is just walking by. There's also a manual emergency SOS trigger using a hidden touch sensor, giving the user control in urgent situations. In security mode, the ESP-32 continuously scans for intruders within a 70 cm range in all of the directions. If no intrusion is detected, it automatically enters deep sleep, conserving power by drawing just 10 microampere. Additionally, when a Bluetooth connected phone comes into range, the system recognizes the owner and enters deep sleep mode to avoid unnecessary alerts and power use.
So now we will talk about the working part of our software project. So this is the hardware component. We have 4 ultrasonic sensors, 1 buzzer for sound alert and 1 switch for switching between the parking mode and the security mode. So when the switch is low, so we will be in the security mode, and when it is high, so we will in the parking mode. And ESP-32 microprocessor chip, 1 USB cable to connect PC and the ESP-32, and we will have 2 wires to act as buttons. So this will be act as an emergency SOS button, and this will be installed in the car security door handles to provide a dual-way security, including sensor and the wire. So this is our code which will be used in the ESP-32, uploaded through Arduino IDE. And this is the output serial monitor showing that we are currently in the security mode. And now we will see how security mode will work. When the user will cross the threshold distance in the sensor, and plus when will the user touch the door handle. Currently we are using this wire. So then the buzzer will sound and the Twilo will send a response message like this: intruder detected and sending alert. See that we have received the emergency alert message from the Twilo. Now this is the BLE part. It is scanning for the BLE device nearby, and my phone will act as car key. So you can see that it is found and detected and entering the deep sleep mode. So this ensures the false alarm that can be triggered by the user when it is near the car. So my phone will connect with the ESP-32 Bluetooth, and when they both are connected, the system will go in the deep sleep mode and the security system will go off. So this is the code we will be using for showing the parking visual using the processing app software. And this is the radar visual we are seeing. So as we can see, as my hand is nearby, it is updating the distance to 3 cm, and as we will go further, it is updating to 11 cm, and the buzzer sound intensity increases as the objects come nearby, and the buzzer intensity decreases as the object goes farther and farther. So this black wire will act as the emergency SOS button. So currently for demo we are using, and we are utilizing the GPIO touch pin of the ESP-32. So as we have touched it, so the buzzer sounded, and we have got the emergency alert from the Twilo that there is some emergency. So
Now that we have seen the complete working, now I'm going to discuss how a result of a solution is better than the existing solutions. So firstly, our solution is cost effective. We have used inexpensive components like ESP-32 ultrasonic sensors, buzzers, so that the entire cost of our project is less than 1000 rupees. Whereas if we see, the commercial system typically requires proprietary sensors, software licensing or professional installation, which significantly increases the cost. Also, our solution provides dual functionality, which is the parking as well as the security in one compact device. Whereas if we see in the existing solutions, most systems either offer a parking aid like the reverse sensors or anti-theft alarms, rarely both. There is a radar-like visualization present in a system using the processing software for real-time visuals, whereas in the existing solutions, many low to mid-range systems rely only on sound or LED indicators, not visuals. We have also used Wi-Fi enabled real-time alarms with the help of ESP-32, which send intrusion alerts via Twilio to the user's phone. Whereas in the existing solution, many basic systems don't offer remote alerts unless you upgrade to expensive smart car ecosystem. There's also low power consumption as compared to the commercial solutions. Our solution is customizable and open source. That means it can adapt it easily with code and hardware changes to suit different vehicle types. Whereas in the existing systems, usually closed source with limited customization is present. So we can conclude that with radar-style visuals, real-time alerts via Twilio and open source customizability, this system brings together smart security parking assistance and energy efficiency all in one compact, budget-friendly package.
Finally, we would like to cooperate with you according to the best of our knowledge. Keep your feedback and suggestions coming. They help us to provide you quality work that resonates with your needs and requirements. Thanks much for sharing your kind suggestions. Keep healthy, keep learning, and keep growing.
KONARK'S Research. Subscribe now.